Closest prime numbers in range. Okay. Given two positive integers left, right, find the two integers num1 and num2 such that left is less than num1, less than num2, less than right. Both num1 and num2 are prime numbers. Num2 minus num1 is the minimum amongst all other pairs satisfying the above conditions. Return the positive integer array as num1, num2. If there are multiple pairs satisfying these conditions, return the one with the smallest num1 value. If no such number exists, return -1, -1. So left, right is 10 and 19. So they're expecting num1 and num2 to be in between 10 and 19. And that's 11 and 13. The closest gap between any pair is 2. But, like, yeah, I don't know how to find prime numbers. But if there was a way to put them in an array, let's just say you had like a prime array of a bunch of stuff, then all we would have to do is, and they're all sorted, right? All you have to do is loop prime array and just find the closest one. So I think the hardest part is just coming up with the prime array, and that's where I don't really know. So I was watching this Sieve thingy. I still don't know how it's called, but yeah, I don't think there was any way I was gonna get this beforehand. So let me just try based off what I watched, try to reconstruct those primes. So the whole idea is we want to start, we have a start and an end, and we want to find all the primes in between. So we know, okay, wait, if it was like one, let me look at that video. If it was, I guess 2 to 100. That's 98. The 2 to 100. It's just right minus left. That's just going to be the length of the array, right? So like if they wanted 1 to 5, 1, 2, 3, 4, 5. So it's 5 minus 1, which is 4 plus 1. That's the length. So some sort of like array is gonna be of size n, and this array is gonna have a flag. I guess it's like a Boolean, right? Whether it's prime or not. I don't know, but you have to say if it's visited. Maybe we'll just say -1. And then for us, we can say that -1 means unvisited. Yeah, actually true or false is fine, I think. Originally it's all false. So then now we want to start from the left. So for I in range, starting from the left, going all the way to the right, inclusive. If we were at 2 times starting from that number, right? So maybe like some molt is that number. So while maybe we have a temp, I'm not so sure. Temp is I. So while the temp is less than or equal to right? If array I think we could say like if the array at I is true. I guess we only care about setting it to false. While temp is less than equal to R, right? Then we'll just do array at temp times mult is actually maybe I'll just do -1. It's like we never saw it, and if we've seen it, then we just turn it to a 0. And then temp times equal to like the mult plus equal to 1, temp times equal to mult. Wow, something like this. It's kind of tough. And then let me just print the array for now, and I could return an empty list. It's tough. Actually, n can just be the size of right. Then we'll just ignore the first left. So, oops, do that. Temp is like that. if the array at I is equal to -1, then it hasn't been seen before, so it's a prime. Then array at I, we could say 1 is equal to prime. So -1 is like not visited, 0 is not prime, 1 is prime. Maybe something like that. Oh, but I guess you need to start it at 0. Kind of need to start it at 0, huh? Yeah, we want to start it at 2. Uh, 0, 1, 2, 3, 4, 5. Why is 6 prime? It should be temp is I. No, temp times equal to I. Mole is 2. Temp is that. So that's 2 times 2 is 4. Later it's going to be 2 is a 4. No. Then you want then you want temp to be equal to 2I times molt. And then molt goes up 1. But I think you want to put molt goes up 1 right there. Temp is equal to I times molt. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, those are all primes. Oh, and then okay, and then now to actually build this prime array is going to be like this, and we just go like for I in range. We want to start at left, right? They give us left, and we want to end at right +1. Yeah, because it's inclusive, so we do right +1. If the array is a 1, that means if the array at I is equal to 1, then it is prime. So we do prime array dot append I. Okay, so then let me just print out prime array. (11, 13, 17, 19). Awesome. That's low-key kind of hard. Okay, so now that we have the prime, how do we find the minimum? I mean, we just need L and R is going to be our smallest. Num1, num2, I don't know. Smallest is equal to float infinity, so it's going to be something super large. We just need to go for n in range prime. So for each number in prime array, starting at the first, so we actually need a previous that's going to be prime array 0. So for n in prime array starting at 1, the difference between n minus prev is the length, right? So if the length is smaller than smallest, then num1 should be prev, num2 should be n. No matter what, prev should just be n. We need to change smallest, right? Smallest to be n minus prev. And then later we just return num1, num2. Let me run this real quick. Awesome. Wow, outputting of 6 is crazy. Wait, that's not good. That means our prime array is wrong, right? Print prime array. Because why is 6 even in there? That's bad. So for 2, multiply is 2, temp is 2 times 2, so that's 4. While temp is less than right, array at 4 is 0. Mul plus equal to 1, so now mul is 3. Temp is equal to 2 times 3, which is 6. While 6 is less than or equal to. Less than or equal to. Oh, this is so tough. So then there's 5. 0, 0. Yeah. I think we can immediately say if the length of the prime array is less than 2, and I can call this before actually doing that, just in case there's nothing exists. If the length of the prime array is less than 2, so if it's 0 or 1, we just need to return -1, -1. Otherwise, we set the previous to the 0, then we loop starting from 1. We just do this check to see if we ever see something smaller than smallest. If so, update our previous and n, which is going to be the result currently, and we just keep looping until we finish. Then we return the smallest neighbors. Let's run that. This should work now. But that's extremely hard in my opinion. If this passed, that's sick. Wow. That's tough, and then it looks like I didn't even do it efficiently either. Huh. My runtime is just really bad. Okay, well let me first try to see what I'm doing I'm creating this array that is size right plus 1. We don't go from left to right because our prime could start, I mean, our prime needs to start at 2, right? So our prime starts at 2 and we just keep filling it out with base 2, or not base 2, but like with multiples of 2. So it's going to be like 2 times 2 to start, and then it's going to be 2 times 3, 2 times 4, 2 times 5, 2 times x all the way until we reach outside of right. And then every time we make sure that that array at temp is set to 0. And since we did 2 times x to get to that temp, that means that it's no longer prime. That temp is no longer prime. So later when we do this with all, when we go through this whole thing, we can loop it once again and say, hey, if the array was 1, we know it's prime. And we set array as 1 is when we first see it as -1, we know that it was not been visited, so it's a prime. So we set array at I is equal to 1. So later when we say array I is 1, we just append that to the prime. All of that, I mean, this is O of right. And then you have to keep going. I'm not sure. I don't know the time complexity of this, to be honest. But yeah, this is a long video. I'm gonna cut it here. I don't definitely didn't do a good job, but I was able to kind of search up this thing, which I think it makes sense in retrospect, but implementing it low key kind of hard. But then once we have the actual prime array, all of this stuff is pretty basic. It's not that bad. It's just creating all the primes kind of tough. So yeah, thanks for watching. See you tomorrow.